Mm, hello.
Yes, ma'am.
Who asked for week 4 question?
No, I didn't.
Okay, let it be. Then we will discuss at last. Okay. Now what we will do? We will go for the question problem. Then chat box question we will discuss last. Okay. Then more students will join by that time. So did you do last week? I gave one question for you to solve, right? I don't know who are the present last week. Anyone remembering?
I was not present in the class.
Okay, I hope this question is I gave last week. Okay, to solve. Because I solved similar kind of question. I told you people to solve this. Okay, now today I will start with that, and today I'm going to solve more on see your fourth week questions. You may see about this um, heat exchanger questions. Okay, how the heat exchanger questions will be. Then you may see the questions of logarithmic mean temperature difference and all. So that kind of questions we will solve today. Okay. So this question is very easy that we already discussed similar kind of question last class. First I will read the question. A cyclic heat engine operates between a source temperature of 800 degrees Celsius and a sink temperature of 30 degrees Celsius at least rate of the least rate of the heat rejection per kilowatt net output of the engine. What is the least rate of the heat rejection per kilowatt? Okay, that you have to find. So from this is a cyclic heat reversible heat engine operates between source temperatures is given. So what is the concept you have to know for that? For a reversible heat engine, cycle will reject least rate of heat, that you can represent it as QL. Okay, so QL will be the least rate of heat, so that you are representing QL, per kilowatt to the net output. Net output will be in the watt, okay, of engine. So for that, for a reversible heat engine, so cyclic heat engine means reversible heat engine, the efficiency eta will be work done divided by QH. So that you can write it as TH minus TL divided by TH. That you can write as 1 minus TL divided by TH. Okay. Now what we have to do, we have to just put the calculation. So if I see here, you see here, what are the things given here? TH is given. TH is what? The source temperature. It is 800 degrees Celsius. Okay. Now that you can take it as you have to, in first class itself I told that for the temperature in degrees Celsius you have to convert it into Kelvin to solve the problem. So it will be 1073 Kelvin. Now TL will be the 30 degrees Celsius, that is like 303 Kelvin. Now work done is how much it is given per kilowatt you have to calculate. So W will be 1 kilowatt. Now we have to substitute the equation. How it will be? If you consider W by QH is equal to 1 minus TL divided by TH, just substitute the value here. You will get 1 by QH is equal to 1 minus 303 divided by 1073. You have to solve it. You will get the value for QH. It will be 1.39 kilowatt. Okay. From there you have to find the value of QL. QL you have to find QH minus W. Let's just substitute the value. You will find the answer. It is nearly 0.4 kilowatt. So first what you have to do, you just go through the questions and solve it and check that you are getting the same answer like this.
Ma'am, answer is 0.71.
No, one, which one? Which one 0.71 you are getting?
QL.
QL
No,
will be
this, no, not QL.
QH.
अच्छा अच्छा ओके 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 करेक्ट 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 करेक्ट
Madam, with respect to the session
0.39.
week 4 and
0.39 you will get, it's nearly equal to 0.4.
hello, ma'am.
Yeah.
So in the assignment 4 and question number 2,
That's what I asked. It is supplementary firing in HRSG, right?
yes, ma'am, yes.
Yeah, the answers are B and D, right? Means burning additional fuel in the exhaust of topping cycle and increases total power output.
Madam, how it is possible? Additional fuel that we will not supply, no? Only that we will make use of the residual fuel in the exhaust of the topping cycle, isn't it?
What? You are saying A answer is correct.
Yeah, answer A is correct, ma'am, not B. Because we will not supply any additional fuel to the cycle.
No, we supply additional fuel in bottoming cycle.
So, but
That
here the
QA.
question is in the topping cycle, you know.
Yes, yes.
Means we are giving additional fuel, right?
No, ma'am, that we are not giving any additional fuel because the main purpose of the heat recovery steam generator is to make use of the heat that is available in the exhaust of the topping cycle. And we will not supply any additional fuel there.
Means residual fuel we are using for that cycle, right?
Yeah,
Not
yeah.
only the extra fuel you are saying.
No, you are not adding any extra fuel there.
Residual fuel only we are adding, yes.
Yes, ma'am, yes.
Okay, then answer will be A and D.
Yes, answer is A and it has to be A and D.
I will note it and I will inform them, okay? To check
Okay, ma'am,
accordingly.
okay. Then now one more thing, ma'am.
The same question like assignment 4.
Yeah, in the same assignment 4. Here in the problem number 5.
Problem number 5. Okay.
Yes. In a gas turbine, the atmospheric air is compressed into 6 atmosphere and the maximum and minimum cycle temperatures are 1200 and 300 Kelvin. Find the ratio of the gas turbine cycle efficiency to the Carnot cycle efficiency and the ambient air is at 1 atmosphere and 300 Kelvin.
Okay.
So in that I got the answer is only 0.43, ma'am, but you also you are given us a 0.53.
Okay, that I will check. I didn't solve it. I will check and get back to you. Okay. If it is 0.43, then I will inform them to correct accordingly. And whatever answer you are getting, you have to, if such kind of thing, you have to answer in that NPTEL portal. Okay, NPTEL, there is some discussion section, right? You should make there because otherwise the mark will accordingly go through this option automatically. Okay, so if any such kind of issues, you should respond in the NPTEL portal itself. Okay.
In the portal or in the forum?
In the forum, discussion forum.
Okay.
Hello, ma'am.
Yes.
In assignment 4, question 2 is right because we add the additional fuel in the HRSG in the bottoming cycle inlet, and bottoming cycle inlet is equal that topping cycle exhaust. So B option is right. There is no issue.
Sir, I think it is not that we are not adding any extra fuel in the heat recovery steam generator, because the main purpose of heat recovery steam generator is to make use of the residual heat, okay, in the exhaust. Then what is the purpose of adding the additional fuel here?
We add the additional fuel because it will increase the temperature, and temperature decrease that increase the quality of energy that we available. So efficiency of the bottoming cycle will increase. That is the
Uh,
purpose.
Sir, I think yeah, I think we have got confused. You please check again, sir, and then please let me. Because it is not that we have to add any additional fuel in the heat recovery steam generators, because it is used for heat recovery. Okay, it is not to make again further additional fuel there.
Indirectly, we recover the heat by increase the quality of energy that available at the exhaust of topping cycle.
Sir, sorry for disturbing you again. So the thing is that whether it is high quality or low quality, that doesn't matter at all. We have to recover any heat that is contained in the engine exhaust or in the cycle exhaust, that we have to make use of it. Okay, that is, we have to recover it. Then what's the purpose of adding any additional fuel there?
That I have told that we increase the quality of energy that available at the.
So the purpose of the heat recovery steam generator is not to make increase the quality of the heat. Okay.
Yes, that is right, but
Mm.
in case we can say that we increase the quality of energy by adding
Okay.
extra fuel.
No, sir. No, sir. No, sir. Please.
Okay, let me check that and get back to you. Okay, it's like
Okay.
both
Okay.
some confusing actually what we would answer. So
Mm.
what you will do, the exact when we are adding fuel, that we have to be cross check
No,
once.
madam. We are not at all adding any fuel in that heat recovery steam generator.
Then where that Q extra comes from?
Hmm?
Yeah.
That we adding Q extra, then where it
Uh,
comes?
Sir, that not adding any extra heat. That the engine exhaust, okay, that is the cycle exhaust, is made again to pass through that. That is the heat that is in the furnace, and that will recover the heat. Okay, that will recover the heat contained in that the topping cycle.
Supplementary word meaning that we add some extra. That's why it's supplementary.
So where it is given as a supplementary. So
Supplement.
supplementary firing means it is not that adding the heat. Okay, please adding the fuel. Okay, there is,
Yes,
we have to recover the heat contained in the exhaust of the system.
supplementary fuel means extra heat. Fuel
No, no,
means
no. See, fuel addition is taking place only at the furnace. The heat addition is taking place, so that is the fuel supply is only taking place at the furnace, not anywhere else.
okay, okay, ma'am. You will check that again.
Yeah, yeah, yes, yes, I'll check it. Okay.
Okay, okay.
Yeah. So did you all for solve this problem like whatever I shared?
Which one, ma'am?
No, this question what I shared all solved, right? Like I hope.
Yeah, yeah, yeah. It's
Yes,
okay, it's okay.
yes.
Okay.
So now we will go to the next part. Okay. Now in this question, in a counterflow double pipe heat exchanger, oil is cooled from 85 degrees Celsius to 55 degrees Celsius by water entering at 25 degrees Celsius. The mass flow rate of the oil is 9800 kilogram per hour and specific heat of the oil is 2000 joule per kilogram Kelvin. The mass flow rate of the water is 8000 kilogram per hour and specific heat of water is 4180 joule kilogram per Kelvin. Determine the heat exchanger area and heat transfer rate for an overall heat transfer coefficient of 280 watt per meter square Kelvin. Okay. So here the question is very big. So we have to be very first. We have to find the heat exchanger area and heat transfer rate. Okay. Now we will first write what are the given parameters first. So here for the hot fluid, okay, it's oil, so we will take the temperatures T1 and T2. Now for cold fluids, we will take its water, right? We can take T1 and T2, small letter. Okay. Now the entry temperature of oil, that is T1, that we know 85 degrees Celsius, it is given. Okay. Now exit temperature after cooling, it will be exit temperature is how much? 55 degrees Celsius. Okay. Entry temperature of water, it is, we are taking as T1 small letter, it is 25 degrees Celsius. These details now it's available. This is T2, T1, small letter T1 is available. Now what are the other two things given? Mass flow rate, right? Mass flow rate of oil is given, that we can write as mH. It is 9800 kilogram per hour. Okay.
The energy
Even
balance, the
convert,
energy balance that we can get the outlet temperature of water.
yeah, so that we can get it from here. This is per hour, right? So we can convert it into seconds. We should do in all our SI units. So we can write it 300 is equal to 2.72 kilogram per second. Okay, so this we'll use for the further calculation. Similarly, it's given that specific heat of oil, so that we can represent as CPH. It is also given 2000 per Kelvin. Okay, so now we have mH, we have CPH, we have. Now we should know mass flow of water, which means cold fluid. Okay, it is given 8,000, so just converted into seconds, then it will be ME is equal to 2.22 kilogram. But I'm not converting, you have to give 8,000 divided by 3,600, then it will be 2.22 kilogram per second. Okay, so these are the parameters we should know first. To solve this problem means it's already given. Now one more also parameter also given, specific heat of water, that's CPC we can write. It is 4180 kilogram Kelvin. So overall
It is
heat
only joules
transfer
per
also,
kilogram Kelvin.
yeah, it's joule. Now overall heat transfer U also given, that is 280 watt per meter square Kelvin. So these many parameters given. Now what we have to find? First one, exchanger area, right? We can represent a capital A. And second, what you have to find? Heat transfer rate, that we can represent it as Q. Okay. Now first to find the heat exchanger area, we have to know heat lost by oil hot fluid is equal to heat gained by the water cold fluid, right? From the water, that oil is gaining heat and getting cool. So that heat both should be equal. So that we can write it as QH is equal to QC. Now we have to apply the formula MH CPH times T1 minus T2 is equal to MC CPC times small letter t2 minus t1. Now all the parameters given except t2. From this you can calculate the t2 value. So if you see here, t1 is given, t2 is given capital, small letter t1 is given, mh is given, cph is given. So just substitute here and find the value for t2 first. So you please first do t2 value and same e2 in the degree Celsius. Okay. So here you solve the problem in degree Celsius like 85, 55 and all. At the moment we no need to convert because we are taking the difference. Yeah, how much you got?
But I need the doubt only on week 5. So since we are not clarifying any week 5 problems, that let me leave now.
1 minute. Week 5, which question you have doubt?
Yes, in the week 5.
Yeah, in week 5.
That is
Which question number?
Yeah, let me tell you.
Answer is 315.5 Kelvin.
Say it in degree Celsius.
Kelvin.
Degree Celsius?
Kelvin.
No. Please tell in degree Celsius.
42.
42.5.
Week 5, fifth question.
Fifth question. Okay, that circuit you are saying.
Yeah. And also the 7th question.
Yeah, 7th question you are asking how to do that.
No, I know, madam. That is logarithmic mean temperature for temperature difference for the counterflow heat exchanger. It is a capital T1 minus small t1. Sorry, small t2. Capital T1 minus small t2. Then minus of capital T2 minus small t1. Then divided by the natural logarithm of the first, this capital T1 minus small t2. Then divided by capital T2 minus small t1. Okay.
T2.
But the answer is I got is 0. But here there is no options. There is 120 minus 70, then minus 90 minus 40. So the value will get us 50 minus 50 is 0.
Oh, okay.
But here the answers are 20, 30, 50, 70.
Yeah, I'll check that. Okay.
So okay.
If you are getting 0 by 0, something like that.
No, log 0 is
Yeah, then you have to apply El Hospital rule, I think. Just go through that, okay? Because means such kind of problem normally if you're doing LMTD, you may get 0 by 0 format. Means it's applying limit, right? Ultimately we are applying limit. You are getting 0 by 0 format, what you have to do, you have to apply El Hospital rule for that.
What is that mean? I don't know.
Okay, just go through that. We'll such kind of one problem we will solve today. Okay.
Difference of numerator and denominator.
You you should not get denominator 0. That's it.
Thank you.
Such situation, what you have to do, the denominator derivative we have to take. Yeah, I'll explain next question accordingly. Okay,
Okay.
similar kind of question. Yeah, where it's coming 0 by 0 form.
Hmm.
I think that we did. Okay, at the moment you got the temperature T2 is 42.5 degrees Celsius, right? From here. So from here you will get T2 is equal to 42.5 degrees Celsius. Now what you have to do, this is the exit temperature of water. Now you have to calculate heat transfer, right? That is the one question. So heat transfer you can calculate MC CPCC times T2 minus T1. Otherwise you can calculate MH CPH times T1 minus T2 also. Or either or this one. Now substitute the values, you will get the Q values. Okay, MC or CPC, how much you got?
163.2 kilojoule.
Like 162 point times 10 to the power 3 volt.
Kilojoule
Huh, enjoyed.
per second.
Yeah.
It is
I hope all got Q value. Q value, finding Q value is easy. Now you have to find the area. What you will do?
Q is equal to UA delta T.
Correct, yes. Now for that you have to find the counterflow first. Delta Tm, right? Now after getting Q value, we just solve Q is equal to UA delta Tm. Which means from that delta Tm you have to first calculate, that is equal to T1 minus small t1 times minus T2
Madam,
minus
this is a counterflow, no? It is the capital T1 minus T2. Capital T1 minus small t2. Because it is counterflow heat exchanger.
But capital T1 minus T1, right?
No, madam, it is only for parallel flow that what you are saying is right. But it is for the counterflow, both the fluids will move in the opposite direction, no?
Yes.
So in that cases, the delta TLM will be given by capital T1 minus small t2 minus capital T2 minus small t1.
T1. Okay.
Yeah.
Log T1 minus. Then here also similar, right?
Yeah, T2, yeah. Capital T1 minus T2, small t2 divided by T2 minus T1.
Then what is the answer you are getting? Just check it.
I think it is 50.2, ma'am. Not this one. This one.
36.39.
36 point.
39.
I got 35.8 actually. Maybe small changes.
What, ma'am?
35.8.
It is okay, I think.
Yeah, I got 35.8. Okay, anyhow, we solve it like using calculator, right? Okay, after finding this, what you will do? Q is equal to UA times delta Tm, right? From
Yes.
that, you find A value. Just tell what will be the A value for this. Substitute Q value, that is 162 times 10 to the power 3 that we solved earlier. And U value is given 280. And delta Tm, like nearly, it's 35.8 in degrees Celsius. Okay. And you solve it. And share the answer in meters square. How much you are getting.
$18.78, ma'am.
How much?
18.78.
You did with which T value?
30.8.
Yeah, you are doing with 35.8 degrees Celsius.
35 में 30. अच्छा 35. Oh, wait man.
Uh-huh.
I misstated.
16.01 meters.
You will get 16.16
01.
meters. Yeah. This
Okay.
answer you should get it, okay?
Yes.
Yeah. It's a lengthy problem.
16.16, ma'am.
Yeah,
That
yes,
is.
yes. Okay, now we will do next problem, like where that temperature value becomes 0 by 0. Okay.
Yes.
Go to my okay, fine. We'll solve it. In the question, the logarithmic mean temperature LMTT of the counterflow heat exchanger is 20 degrees Celsius. The cold fluid enter at 20 degrees Celsius. Okay. The hot fluid enter at 100 degrees Celsius. The mass flow rate of the cold fluid is twice that of the hot fluid. Specifically, heat at the constant pressure of the hot fluid is twice that of the cold fluid. The exit temperature of the cold fluid we have to find. Okay.
Which question that you are discussing?
Oh, you are unable to see this.
Yeah.
All of you.
No, ma'am. You can able to see.
Visible.
Visible,
No,
ma'am.
this, I'm not asking about this question. I asked about another question. In week 5,
You're also asking similar kind of question, right? Where you're getting the denominator 0 temperature.
okay.
Yeah. Here also it will come.
Okay.
Because we are applying we are going to do LMTD, no? They're also
Yeah.
saying you will get log value below 0 by 0. Right?
Okay.
Okay. So actually what it is given here, if you draw it like this, so temperature 100 degrees Celsius is 20 degrees Celsius, and we don't know TC2 value. Here we know the value 20 degrees Celsius. Okay. Now we
Okay.
know that in questions it is given that the mass rate is equal to rho x times the mass rate of hot fluid, right?
No, how do you got a 40 degrees Celsius as a hot fluid outlet temperature?
Which one? Which one?
Hot fluid outlet temperature, sir.
This one.
Hot fluid outlet temperature, man. 40 degrees Celsius, how you got it?
Yes, ma'am, that is not given in question.
Hot fluid outlet temperature, you posted as 40 degrees Celsius.
Okay,
But how
it is
you
not
got it?
given the question, right? It is there.
Yeah.
Okay, like I didn't explain the question. And one more criteria, it is given CH is equal to 2cc. Okay,
Yeah.
according to specific. Now we have to do the energy balance, right? So we know that mH CH time TH1 minus TH2 is equal to MC TC time TC2 minus TC1. Okay?
Yes.
From this what you will get?
Given equation.
CH is 2cc and all, and mH is equal to that all. Finally you will get TH1 minus TH2 is equal to TC2 minus TC1. Okay, because both will cancel each other. There. Okay? Are you getting? Just substitute here mH value and the rate values, okay?
Okay.
Then you will get only this temperature relation.
Yes.
Okay. Then here you go for LMTD formula. But it will be TH1 minus TC2 is minus of TH2 minus TC1 divided by log of same formula. Okay?
Yes.
After going through that, what you will get? This LMTD. Okay. Let me write one more thing here.
But here the outlet temperatures of both the fluids are not given.
Yeah, we'll solve like that.
We will have two equation of T2 and
we have to substitute those equation values actually. Yeah.
yes.
Given TC1. Okay, we will write like this. This you can take it as theta 1 is equal to theta 2 for easiness. Okay. Now our LMTD equation, how it will be? It will be
Theta 1 minus theta 2
minus theta 2 divided by log theta 1 divided by theta 2.
Yeah.
That we are calling as theta m. Okay?
Okay.
Now how to solve it? We are taking theta 1 divided by theta 2 as x. Okay?
Okay.
Now what will be our theta m? We can write it as q1. Okay.
Theta 1 minus theta 2
this you can
divided by log x.
q2 minus x minus 1. Now just everything change in terms of q2. Substitute q1 as q2. Here you will get it, right?
Okay.
q1 is equal to q2x. So you can write it as like this. Theta 2 times x minus 1 divided by log x. Okay?
Okay.
Now you have to apply the limit here. So limit x tends to 1, theta 2 divided by x minus 1 divided by log x. Okay. Here what you will get? You will get in the 0 by 0 form. If x tends to 1, it will be numerator will be 0 and log 1 will be 0. So 0 by 0 form you will get. Are you getting?
Yes.
In such situation what we have to do? We have to apply L'Hospital rule because we are applying the limit, right? So applying L'Hospital rule, we have to write theta m is equal to q2 divided by derivative of this log x. It will be 1 over x. Okay. From that, we will get qm is equal to qt is equal to q1. If you get theta m is equal to how much then? 20 degrees Celsius, right?
Okay.
Hmm? From here. That is same
Okay.
as is equal to Q1 is equal to Q2 from here you will get. What's wrong? Okay, let me write here. You will get Qm is equal to Q2 is equal means theta m is equal to theta 2 is equal to theta 1. Okay. So
Yeah.
from that theta m you will get the value 20 degrees Celsius, which means Th1 minus Tc2 is equal to 20 degrees Celsius, right? Th1 is given 100. So 100 minus Tc2 is equal to 20 degrees Celsius. From that you will get the value of Tc2 is equal to 80 degrees Celsius. So this will be the answer. So I hope all you understand, right? Or do you want some more time to do this?
Okay, but I need some more.
Yeah,
I have to put some more time on it so that I can able to understand.
yes,
Now
yes.
I am not
The
clear.
only thing is just health hospital rule we have to remember. Okay, that is nothing but you have to give the derivative. If you are getting 0 by 0 form, what you
Hmm.
have to do for that equation from the you have to take the derivative of the denominator. Like log x,
Hmm.
its derivative is 1 over x. That only
Hmm.
you have to give. Just read about health hospital rule. It's very easy. Because some kind of problems are there. When I said that's for this to solve, the 0 by 0 forms are coming for some problems.
Okay, thank you.
Yeah, welcome. Actually, in this area, you can see the problems like first one is LMTD related problems. Okay, you have to find LMTD some cases. Otherwise, you have to find the exit temperature. What the problem now we did. Another kind of problem is you can find mean temperature difference. Okay, mean temperature difference, and some other problems also there. You have to calculate overall heat transfer coefficient, like they will give the temperature and the tube diameter and tube length, specific heat and all. You have to find the overall heat transfer coefficient of that system. Such kind of problems also there. Okay, so related to heat transfer there are different kind of problems, mainly on LMTD, but some cases it may ask some other kind of questions also. And sometimes they may ask like outlet temperature of liquid, outlet temperature of water, and effectiveness of heat exchanger take care. much it effective. So such kind of questions also available. So we will solve 2-3 problems today, like remaining we'll solve next class. Okay, regarding this heat exchanger part. Then we'll start with the week 5 questions. Okay?
Yes, ma'am.
Yeah, yes. So shall we move next problem? Like that is related to you have to find mean temperature difference. Okay.
Okay.
Yeah. Mm, yeah, this question. Yeah. See this question. In counterflow of heat exchanger, cold fluid enters 30 degrees Celsius and leaves at 50 degrees Celsius, whereas the hot fluid enters at 150 degrees Celsius and leaves at 130 degrees Celsius. So if we draw here, but you can write actually what will be the normal diagram for this THI heat temperature, and if you draw like this it will be TCE and here TH and TCI. So the difference will be delta TE and here difference will be delta TI. Okay. Now you know already LMTD formula. Okay, in the LMTD formula, but it will be delta Ti minus delta Te divided by log delta Ti divided by delta Te. Okay, now from this what it is given, like we have to check. So THI and TCI are the temperature at which hot or cold water enter respectively. So TI, the I representing the entering the system, it may be hot water or cold. Okay, and THE and TCE are the temperature at which hot air and cold water exit the system. Okay, now what as normal we'll do, we have to balance the counterflow of the heat exchanger. For that we can write it as m dot h ch is equal to m dot to c, that we can represent as capital letter C. Okay, now we have to solve the problem. Now what are the things is given here? TCI is given 30 degrees Celsius, TC is given 50 degrees Celsius, and THI is given 150 degrees Celsius, and THE is given 130 degrees Celsius. Now you have to calculate what they ask. Delta TI you have to calculate. Similarly delta TE you have to calculate. So delta TE is this one, delta TI is this one. Delta TI is THI minus TCE. It's everything is available here. You have to just subtract. You will get the answer 100 degrees Celsius in both cases. What it mean by this? Both the changes are equal, right? Both changes will be 100 degrees Celsius. So the heat exchanger is balanced type counterflow. Okay. So the mean temperature difference of in this case will be 100 degrees Celsius. So such kind
Ma'am,
of, yeah.
ma'am, can I ask in this during counterflow some pinch point is there? Can you say something about the pinch?
What?
Pinch,
Hinge point.
PINCH, pinch point.
That I have to check 1 minute.
It is like a terminal temperature difference. There is temperature difference is always in the heat exchanger. That is mean pinch point.
Okay, sir, that pinch point should not be more, cannot possible more than 10. What will be the reason, sir? More than 8.
That it is maybe specific case, but it is always more than zero. We can say that. But if you take ideal case, then it should be more than 800, 8 degree or something like that.
this is the my question, sir. Why it should not be more than 8?
What?
Is it not possible that we can design a heat exchanger more than 8, the pinch point?
Yes, that more than 8 in this case also it is more than 8 degrees Celsius. We cannot design the heat exchanger at a negative temperature difference there. Hot fluid and cold fluid.
But I think this pinch point will be depends on the minimum temperature difference, right?
Yes, ma'am.
Uh-huh.
That should be not negative.
Yeah, and that is obviously negative temperature should not be there. And one more thing, like it depends on the system also, like the temperature difference between the heat and cold fluid, right? Not only it cannot be a fixed value also.
Yes. But I think that Mr. Jitendra Singh take specific case that practically it is not more than 8 degrees Celsius, that something like. But theoretically it should be zero also. It can zero.
Yeah, means both temperature, like
Uh,
hot and cold, both can be same value.
can be some
Huh.
theoretically, but
Theoretically, yeah.
okay. But practically it should be not more than 8 degrees Celsius.
Yeah, if both are same value, then no need to go for heat exchanger, right?
Okay.
Yeah. Um, I hope this question also you solved. Now time is running out of. So what we will do? See these kind of questions. Okay, this we will solve in next class. But just go through it. See here what are they given? Temperatures are given, and tube length and diameter is given. Specific heat also given. Velocity of the oil is given. You have to calculate the heat transfer coefficient. Okay, this is a one kind of questions available. And if you see this one, you have to find the outlet temperature. The details you will get, but outlet temperature of water, and effectiveness. So such kind of questions also possible. And if you see overall heat transfer coefficient, so heat transfer coefficient is one kind of question, and remaining these are just normal effectiveness you have to calculate. So such kind of questions also we have to solve. So at the moment what we will do, we will stop here. So today three kind of questions we discuss. First one is
Ma'am, can you show me once more the questions you shown?
like these two questions.
Yes, ma'am. Just show the question.
Yeah, yeah, you can take photo or screenshot, whatever. Just go through it, okay?
Next one, ma'am.
Next one, this one.
Yes, ma'am.
And one more, this one also. It's normal kind of question. Okay?
What about my question that I asked initially?
Yes, yes. Mm, okay, that I have to discuss with that NPTEL TA people. Okay, once I'm not. Mm, like, you will attend next class, no?
Ma'am.
Yes.
Yes, yes. Then I will answer this, okay? Let me note
Okay.
it. Yes, yes.
Ma'am, very good class, ma'am. I continued. Means every Monday it is there, ma'am, 6 to
Yeah,
7?
every Monday 6 to 7.
Yes, ma'am. Thank you, ma'am. Thank you. We will attend, ma'am.
Yes, yes, yes. And I will try to answer your doubt. I'm also not expert, but I will try. Okay. So see you next class. You try to solve these three kind of problems. Then we will see next class. Okay.
Thank you, ma'am.
Yeah.
Good night, ma'am.
Bye.
Should I send it my question into
Yeah, you
forum?
should. put it in forum also, okay? Because I am just PMRF TA. There will be NPTEL TA. There are two NPTEL TA for this course also. So total 3 TAs. So we will discuss. I took this question actually. We will discuss and we'll try to answer in the NPTEL forum. Now itself I will inform them, okay?
Parmar sir, can you give your mobile number?
Uh, I'm not allowed to give that.
Like we talking about me.
Yes, ma'am.
Okay,
Parmar
okay,
sir.
fine. That you can. Yeah, you please note it, then I will leave the meeting, okay?
Just send hi in WhatsApp.
Yes, ma'am. This 9510954345, sir.
Yes, yes.
Yes, yes. Thank you,
That
ma'am.
was
Thank you.
my
Thank you,
WhatsApp.
sir. Thank you, Parmar sir. I will ask.
Yes.
Okay, okay, no problem.
Bye then. Bye everyone. Good night.
Good night, ma'am.
Thank you, ma'am.